Oh, there. This is stream number 37. So I actually should put up a big block diagram of what I'm working on, but haven't quite gotten that ready. I'm working on making my own web server in C++ from scratch, basically, just using standard library. And this is 37 streams in now, so we have a web server. It does serve web pages and a little bit of dynamic content. We've been working on a chat room sort of to demonstrate WebSockets. And for the last couple streams, I've been chasing down random bugs and little missing loose ends. So I'm going to be working on that today a little bit more. So in the past, I've been using standard shared pointer, which is a C++ reference counted garbage collected pointer, I guess you could think of it. I've been replacing that with references for methods that are synchronous and don't need to hold references. And this is sort of a optimization and maybe an adjustment to the style I've been using. I guess I've been overusing standard shared pointer. Someone pointed out to me that, no pun intended, that overusing it just unnecessarily makes my code a little bit less optimal. So we're going through and removing shared pointer and just using normal C++ references where we know that we don't need the reference counting. So not sure how long that'll take, but if I get through that, we'll be working on improving entity tags in our web server. Right now, just using a simple checksum. I'd like to leverage our secure hash algorithm 1, or SHA-1, to calculate the entity tags. Then next up, I want to handle the clean breaking of connections. We have a class called network connection that is cross-platform so that you don't have to worry about how sockets are implemented on each OS. But right now, when you tell it to close or break a connection, it does it very abruptly and doesn't wait until all of the data that you've queued has actually been sent. I noticed a bunch of other places in the code which I wrote a while ago before streaming aren't really following my own guidelines on the rule of 0 or 5, so we're going to go clean that up. I'm going to collect together and refactor a couple functions here and there where I have strings being converted into integers. And I'm not using the C standard library scanf because mainly it doesn't detect if you have non-integer garbage after the end of the integer. And so I wanted that, and so made my own function for that. But I did not put it in a place that could be shared, so there's basically copies everywhere. I need to remove that out and put it in one place. And then there's a bunch of places in our chat room unit tests where we're using a bunch of sequential calls to JSON set that I want to replace with a single JSON object call just to make it look a little nicer. And if I get through this entire plan, our code I think will be in a lot better shape. After today, there's 2 goals I want to get, and I think they're captured in my roadmap on the medium and long term. Okay, I guess I didn't, but let me put that in. Oh no, it's on the short-term plan. We've already done this. I can remove that from the plan. What I don't have, I have this chat room WebSocket demo. What I don't have is a way to host it on an external server so that you guys can interact with it. I'm still researching Amazon Web Services and setting that stuff up. And I need to make sure that I kind of protect myself from, people logging in and saying bad stuff. So I'm going to make it a little bit more restricted than the chat room is now. But it should still be kind of a fun thing. And maybe then we'll slide into secure connections. And here I'm not going to do it from scratch. I'm going to kind of deviate a little bit because I'm not very good at cryptography. I'm going to leverage an existing transport layer security library. There are a few out there that I'm going to try to pick from. Once that's done, I'm going to be, I think, going to work on this Twitch spot. Maybe extend the chat room demo so that it integrates with Twitch. I have to think about that because there might be some crossover. That'd be fun to do. Or we'll see. Hey there, Rally Monkey. How's it going? So yeah, and eventually after I have Amazon Web Services set up and I have some TwitchBot stuff going. I want to tackle this more ambitious goal, which is to make my own blog system that is not based on something out there already like WordPress, but kind of make it like WordPress. Something where I can go in there and blog and not have to worry about changing code, but just go in there and make posts and then have sort of the nice feeling that that I've made the whole thing and that I'm not reusing someone else's code. So anyway, I guess we'll get straight into it. I was in the middle of this task yesterday, so replacing shared pointer with references. And I had replaced them already and fixing up these places where something that used to be a shared pointer no longer is, needs to, and the Visual Studio is really nice and puts a red squiggly on all these places where I need to change things. So we're getting right into it. Since this is mostly refactoring, I'm not going to be changing tests unless the tests are broken. We'll just be leveraging the tests to make sure I didn't make any mistakes. Okay, yes, this takes a pointer to a connection state. Gonna be a lot of those. And I think this is the same thing, right? Yep. I'll be really embarrassed if that was the only thing I needed to do to fix it up. Because I kind of ended the stream thinking, oh, I'm only halfway through that. Yes, yeah, there's still some more. So we're good. No embarrassment required. Yeah, this, I think our delegate changed, right? Oh, no, it's the request. Request, the resource delegate doesn't take pointer to request, it just takes a request now. So that changes to a dot, that changes to a dot, and we're good for that. More red squigglies, probably the same thing, right? Okay. Why was that not a const? I don't know. Doesn't matter. All these become dots. Ah, here we go. Here we just do this thing. Barky bark, someone's home. I hope one day that my dog will not bark so much when anyone comes in or out of the door. Okay. Dot here. So Rally Monkey, I think one challenge that might be kind of fun, like from yesterday, was I kept looking for like easy onboarding for C++, like some nice step-by-step graphical intro that wasn't intimidating. Like whenever I would look them up, I'd see like, oh, it's gonna be 50 lessons long, and you won't really do anything cool until lesson 36. This might be a challenge for you and I to work on, is to get a step-by-step tutorial that is like hands-on and gives you results right away that introduces you to C++. Because I could not find anything out there that I liked. Okay. We're done with static content plugin tests. I'm moving on to Chatroom plugin tests. Okay, it's the same kind of thing. All of our requests do not need a reference count. There, I actually got rid of a star. And here again, right? Cool. Alright. Next. How come this is off screen? I want to see that line number. Okay, line 807. By the way, if anyone is watching this and has questions, feel free to ask. Because a lot of the time, your questions help me realize that I'm skipping over things that I should explain, or actually, sometimes people ask questions that it helps me realize I'm not doing something correctly, or not doing it clearly enough. And if anyone wants an overview of what I'm doing, just let me know. Now that I'm on stream 37, it might do for once in a while to go back and give a introduction. See, Raleigh Monkey, it's your newbie perspective I could use. So, like, what would you want to see in terms of an intro? Like, how much detail versus immediate results, right? I just don't like the ones I saw out there. I could see like people look it up and like get intimidated and stop looking because they're like, "Oh, this is too hard." Whereas something like React, I got something running in React like in like 15 minutes. And it wasn't very intimidating. There's only like 3 steps. So that's the goal for C++ intro, I think. Make something that within like the first 2 or 3 lessons you have something cool. Maybe you can cheat and use library for doing the graphics that's already out there. But something that doesn't need a lot of huge learning curve to use. Okay. Oh, actually done. Okay. I didn't think there would. I didn't think it would be done that quickly, but I guess I was lucky. Oh. Okay. I'd run the test earlier and didn't notice I had failures. That might have been because it was in a temporary state. As in not compiling at all. Okay, so we're back to everything passing. Cool. Let us see what is actually changed. Okay, the HTTP is probably the deepest one. Yeah, all of this is going to be removing shared pointer where we don't need it. In fact, I'm going to write that now. Remove standard shared pointer where we don't really need it. Or don't need it, not really. We don't need it. Okay. Done with that, and move on to Websocket. What did we change there? Same things? Okay, and no real changes there? Huh. Oh, web server. I was reading that wrong. Web server. Yeah, so it's the same thing. It's remove shared pointer where we don't need it. Can I briefly go over the reason it went away from shared pointer? Yeah, let me do that. So, commit that. Let's find an example. Let's find an example. Just look. Hold on. Let me find one. What if I look at it from a test point of view? Okay, here's one. So this is the test for upgrading a web connection, right? And this is the code that gets run to handle the upgrade. It used to be that it was given the request as a shared pointer. But if you look at where request is used, it actually isn't used at all. It's perhaps used if the delegate wants to use it, but otherwise it's not needed. So there's no real good reason to make it more than just a simple reference count or reference. This is what it looked like before. It was one of these, right? Whoops. Oops. I hit a wrong key and shifted my desktop. Okay, this is what it looked like before. When you do that, passing by value a shared pointer, every time you do that, there is like a call to increment the reference count at the beginning of the function, and at the end of the function, it decrements the reference count, and then if it's 0, it goes and destroys the object. It's all unnecessary because it's never going to destroy the object because it was passed in from the caller. The caller has to already have its own reference. So it's completely unnecessary to add 1 and remove and then subtract 1 and then check if it's 0, because it's never 0. And we're not keeping a copy of that request's pointer beyond the lifetime of the function anyway, so it's all just wasted stuff. If you make a C++ reference right like this, it really just compiles down to a pointer with no overhead. So if this delegate is called very frequently, that could slow things down, right? You have all these +1, -1, is it 0? For every single call. Imagine that's done in a tight loop somewhere. That waste adds up. So it was like a viewer who suggested that unless, like for the case of this connection, where we keep a copy of it, that copy is held here, right? And is captured by reference here. We're holding on to a copy of the object, so we are going to increment the reference count and not decrement it. So it needs to remain a shared pointer. And why I had stuff like that initially is it was just very convenient, because then I don't need to worry about taking a reference or dereferencing. So it was just laziness. So there's a little bit more you have to do. You have to remember to make a reference, right? And then you need to decide whether or not it's mutable. So in this case, the request, the server is going to assume that the thing that handles it is not going to need to modify the request, because that doesn't really make sense. So I decided to make it const. But it's the overhead. It's the mental overhead that I have to remember to put the and, and decide whether it's const or not. That's the cost. The gain is once it's compiled, it's much faster. So how'd I do explaining that? And oh yeah, everything was still building, right? So oops. Okay. There was one other repository that I touched. The root one. What's this? Oh, I think those files don't need to be there. Cool, alright. I think we're done with this item. I can move on now. This one here means that I have one change locally that I haven't pushed upstream. I think I'm gonna, instead of pushing throughout the stream, I'll wait until the end of the stream to push stuff. Because then I don't have to wait. It doesn't break my flow. Okay. Moving on to using SHA-1 to calculate entity tags. So let's see, that is in the server. Actually, it's in the static content plugin, right? Which has its own tests. So let's do the proper test-driven development. I probably already have a test, right? Serve test file. Oh, conditional get with matching entity tag hits code. Here we go. Let me expand all these things. Okay, so right now we just get the entity tag from the server and then verify that if we use the conditional request that has the matching tag, we get a not modified 304, which is the whole point of that is that if the document's really big, but you know the entity tag and it hasn't changed, you won't get the body. It skips the download. More efficient to just check to see if what you have in your cache is still correct. But this test is not verifying that the entity tag is constructed in any given way. So let's add, should I add that to this test? Yeah, actually no. I'll make it a test because it's a different concern. We're not going to do a conditional get. We'll say entity tag computed from SHA-1. That'll be our test. We're going to need SHA-1 as a dependency though. And while I'm at it, maybe I'll add it to the plugin as well. I kind of know in advance that both of those components are going to Gonna need SHA-1. CMake dot. We need to run that whenever you change any CMake lists. And that modifies our project file, so Visual Studio lets us know and asks us to reload. And I do that first because I can take advantage of just the autocomplete here. Okay, so in that test, we're going to create a file that just says hello, right? And we'll configure the plugin, send the request, send request to get the entity tag, yes. And then we will verify entity tag was computed from SHA-1, or was computed using SHA-1. Let's rename this actual e tag, and we'll say that the expected e tag is SHA-1 string of whatever I put in the file. Okay, maybe let's make that a constant. Test file content. Then I don't have to hard code that 6 anymore. I would just do that dot length. Convert that to a C string. I think it wants a C string. It wants a pointer. Actually, I guess I could use data. That works too. Okay, so that's test file content. So expect equal expected e tag actual e tag. And we don't need the rest of that test. Web server static content plugin. Oh, did I not? I didn't update this plugin to build the same way as the other plugin. Let me fix that. It was the Chatroom plugin. I added rules in here somewhere. Okay, maybe it was in the Chatroom. That was a test for the chat. No, that's the plugin. It was in the test, I think. It's in one of the two places. I think it was this one right here. This rule. I just wanted to make the plugins and their plugin tests build in the same directory, so I don't have to worry about copying them around. See, I didn't do the same thing here. So let's do that. Let's do that now. I want the test to build in the same directory as the plugin itself. Because I want to run it like that. There we go, like that. Right, so it fails right away because we're just using a simple checksum now, and here's the hash of the test file itself. So our test is ready. Now we just need to update the code. So the code's going to need the same library. I even have a to-do here. I think all I need to do is say it's equal to SHA-1 string of the buffer. I think that's all I need to do. By the way, another optimization we could do. Right now, it's reading the file, the entire file into memory, and then computing its hash. A smart thing to do, especially if this file is served a lot, is to have some kind of in-memory database that maps between the file's path and the entity tag. And maybe the first time we would have to read the file and compute the hash, but then after the first time, we would just read from our in-memory database. Cool. So that was short and simple. I think I'm going to make a future note for that So static content plugin, optimization idea. Keep database in memory or out. Mapping file paths to entity tags. Some notes about that. First time or cache miss, compute entity tag and store in database. We need to check or detect if content actually changes. So some ways you could check, we could either monitor the directory for changes, or we could check the last modified time stamp of the file, right? So some ideas. Okay. No, it's web server. We have a modification. That's what that M means there. Okay. Actually, I did two things. Let me put this one separate. I forgot to do that earlier. So static content plugin. Build tests in same directory as plugin. This is done for convenience so that the test always has the most up-to-date build of the plugin when it tests it, when it is tested. Okay, and in this one, static content plugin, compute entity tags using SHA-1. Right, now I'm gonna git push. Let's move on. Alright. Do I want to do this one next? This is a harder one. Maybe I'm gonna cheat a little bit. I'm gonna move that down to there. That's a hard one. I want to save that one for later. We'll get through some of these easier ones. So clean up lifecycle methods not following rule of 0. So I think the way to find that is look for places where I do operator equal and just go through them all, make sure they're all grouped correctly. So that's correct. That's almost correct. We're missing 2, right? This would be correct for rule of 3. Well, it's actually not because it's move. We're missing 2, right? Impl, const impl, what is that? This is reference, that's R value reference. I think this is what we want. We want to declare them as deleted. Oh, and the other thing I want to do for all these is do no except. That's basically declaring that we do not throw exceptions from these functions. That can help the compiler out a bit in its optimization. And we have to repeat them here. Okay, next. Okay, these are special assignment operators. Oh, it looks like there's a bit of inconsistency. Sometimes I have a space after operator and sometimes I don't. What's better? No space? Or a space? Oh, I already messed that up. I can't decide. What looks better? That? Or that? Or maybe even that. No. I'm gonna go with that. I think that's what I've been doing. It's just a few of these oddball places I forgot. Let's search for that again. Operator space equals. Okay, so now let's search operator equals no space. Yeah, that's what I thought. A lot of places to look through. Okay, this is almost right. So I really should fold that into the plan. Specify no except. Have all 5 methods or none at all. And then no space between operator and equal. Those are the changes we're making. I think the no except thing is most important for these move constructor and move assignment. There was one place where I can't remember what it was, but it might have been Visual Studio. It was not using the move assignment or construction just because it was in a context where it couldn't throw exceptions, and so since I didn't say no except, it just wouldn't work. But if I said no except, it could say, oh, I can use that now. And you want to, if it's available, use the move semantics because it's a lot cheaper. It's usually a lot cheaper to move an object than it is to copy it. Yeah, so all of these need the no except keyword. Whoops. I clicked on that and it, oh, because it's, yeah, it was folded. Okay, there are a lot of these places I forgot to do this no except thing. Okay, that's different. I suppose we should say no except for those too. Let's put that on the list. Apply no except. Should I just make it a rule to apply it everywhere where we know we're not throwing exceptions? Probably should. But that's going to be a tall order. I'll put that in the to-do Excalibur. Oh, these stuff. I keep forgetting to do these things too. Maybe we'll do that this stream. Make all functions and methods no except unless we do need to either throw exceptions or allow them to be thrown from other functions called that we don't catch ourselves. I'm used to doing code where it's just globally disabled exception handling for embedded targets. And so I don't really use C++ exceptions much, but I've been learning that you should at least tell the compiler what the exception semantics are, and saying no except is it can help, especially with the lifecycle management functions. Right. Okay. Yeah, this is quite not quite. It's everywhere that I forgot to do this. And we're not going to worry about comparison operators yet. Okay, where was this one only has 3. Oh, because they're deleted, right? Okay, so here's an instance where some code is pretty old and predated me making a separate section for this. Lifecycle management. So it's just a style thing. I prefer to have them all 5. If you have to have one of them, you have all 5, and then I don't bother providing the block comment for them because they're pretty much language boilerplate. It's just a personal preference. So that's what it looks like. Okay. Are all defaulted. Okay. Okay, this one's already done. That one's already done. This one's just missing no except. This one has no except in 2 places. This might be the one where I encountered an ability to optimize unless I had no except. That might be the one place. Okay, here's another one where we're missing lifecycle management declarations being explicit. Oh, and here's a case where I think I don't need this constructor. Let me delete it and see if, well, hold on. Let's comment it out. See if we can get away with not having it. So, where is it? Here? I commented out so that I can bring it back if I need to, but I'm pretty sure I don't need it. Okay. Alright, so we need the const equals delete. And this one's deleted also. Okay. And just to be consistent, let me move them to the top. So right there. And where's the, oh, here's the other one. That moves there. Actually, let me build now. If it makes do without the special constructor, then I'll be happy. Looks like I broke something. Oh, probably because I changed things in one place and not the other for a lot of these. Yeah, so it's no except. Ah, so yeah, this is the old way of doing it, so get rid of that. No except. Actually, this is the constructor. What am I doing? Huh. I don't know why that's giving me issues. Okay, build again. Attempting to reference a deleted function. Implicitly deleted because the explicit exception specification is incompatible with this. Really? There's an implicit declaration, it says. Okay. Attempting to reference a deleted function. What's... I don't see why it's implicitly deleted. Explicit... Oh, okay. I think I know why. It's complaining about this, and I need to go to where it's implemented. Oh, it's implemented by default? Oh, is it trying to tell me that copy constructors, the default ones, are don't have no except? Is that what it's trying to tell me? I think that's what it is. I wonder if that means I should only put no except on the move and the destructor. Considering it. Because perhaps, I think what it is the default generated copy constructor is going to copy this standard string, and standard strings copy constructor probably doesn't have a no except clause on it. Let's see, that's basic string. Okay, can we actually see it, or is it going to be too hard to see it? No, it's okay. Yeah, see, there's no except here. Where's their move constructor? I'm looking for it. Okay, I don't see it, so I'm going to go back up to the top and search for... Oh, yeah, see, okay. They do the no except thing for move, but not copy. So maybe I was thinking a bit wrong. So what about their destructor? The destructor is no except. Okay, I guess let's adopt the same convention. So the convention will be copy construction and copy assignment are not guaranteed not to throw exceptions. They might throw exceptions, but the other three are guaranteed not to throw exceptions. Let's do this. Yeah, let's adopt the same policy. Then we're in alignment with the standard library. And here and here. Here and here. And that's the one we just did. Here and here. Right, okay, moving on. Crypto random. Diagnostics context. Diagnostic sender. Directory monitor. Dynamic library. File. Ah, here we go. No except for these three. These not no except. Okay. And these need no except for those three. Huh. Not found. It can't find that? It should find it. It's right here. That's weird. Is it because vector's not included? It's included. Why does it not think that that's... I think it's an IntelliSense problem. It's right here. I bet if I went to declaration, it finds it. No? That's really weird. Operator standard vector uint 8. Operator standard vector uint 8. Const, right? Const. So what's the deal? I don't know. Moving on. Yeah, those are special assignment operators. Okay, so we're missing no except here, here, and here. This, remove it from these. Ah, okay. This one predates, so before the normal methods, it's lifecycle management. And we move the destructor, copy constructor, move constructor, assignment operators. Move these up. Move them to there. And this is a no except. Those 3 are. Okay, next. Those look good to me. Looks good. Oh, let's build. I still want to see if that's actually needed. If it's not, I'm going to remove it. I don't think it's needed. I don't see anything hitting that. Yeah, I'm just going to remove this. What there was a special constructor which took the implementation, this guy, and put it into a new one. So it's sort of like a half-ass move. So we have a proper move constructor and move assignment, so I don't think this is ever really needed. Okay. Yeah, this is just missing these specifications, right? And here again. Looks like it's gonna build, but I'm gonna do one more pass over it. Maybe from the bottom up. Yeah, because these are missing it still. I did not get them all. And these overspecified. And again here. Did I do that one, last one correctly? Yeah. That one, and that one. No. These are in a weird order. This should go down to here. Right. These, whoa. No except, please. Thank you. That one, and that one. I think we're almost done. Okay, these I remember doing. I think we're done. So hopefully that builds and my test will run and we should be good. Run those unit tests. Ooh, I broke something. Hey. Test, debug, WebSockets tests. Eh? Okay, didn't expect no output. Let's find that. Here it is. Set that, go. Exception thrown from, whoa, from the main startup? Something's really wrong. Let me rule out something. Let me rule out that it's a compiler fluke by telling it to rebuild all. Occasionally that'll happen where you see something really strange. It doesn't even look like it's in your code. It never even got into your code. And rebuild and you never see the problem again. Why bother debugging broken tools? You can just get around them. Yeah, so it's a fluke. So there you go, people. You've seen a Microsoft compiler fluke. I mean, if your stuff builds and then doesn't run, and then you just say rebuild all and it does run, I mean, unless you did something stupid in your build system, it's just a fluke. Some problem with the tools. Okay, one directory up. Let's mugget status local only. Oh boy. Okay, so that was that rule of 5.0 lifecycle management fix up stuff cross-cut a lot of things. So let's go deepest out. So that's the URI. Actually, I'm going to cheat here. I'm just going to do an add dot and the git commit m refactoring make application of rule of 0.5 consistent. Very, very late question. All right, can I briefly touch again on no except? Okay, yeah, let me check this in and I'll get to that. The reason I'm doing this on the command line is I think I can go a little bit faster, because on HTTP I can just repeat those same two commands. And I already lost the context of what is modified. Okay, HTTP network transport, so git add, git commit, JSON, git add, git commit, message headers, system abstractions. This is where I should have been smart and had two consoles I could flip between. It's only 3 more though. UTF-8. And Websockets. Okay, so I think what I'll do to address what is no except is we'll just look it up in the manual, and that'll be my little guide. You can talk about it there. No except specifier. Can I make this bigger? Oh, okay. I apologize for it being small, but okay, this is really too dense. This is not really going to really help me explain it. Okay, so here, this is maybe the most succinct description of it. It used to be that you had to say throw and then empty parentheses when you declare your function. Or if you actually did throw exceptions from a function, you'd have to list what types. You'd say throw and then parentheses, you list the type names. So throw without anything is basically telling anything that uses your function that you guarantee you will not throw exceptions. So what they did is they deprecated that and they replaced it with just the keyword no except. So if you see no except for a function declaration, it means the function guarantees it won't throw exceptions. So that allows the compiler to do some optimization, right? If you can guarantee you're not going to throw exceptions, it doesn't have to compile in like code to unwind the stack or otherwise handle any exceptions because it knows you're not. So I do it for, let me show you again. Any of these, right? For like the move constructor, because it allows the move constructor to be used in cases where there needs to be a guarantee that no exceptions will be thrown. If I left that off, and then we're in a context we're compiling something where a network endpoint is being passed from one place to another and we could move it, it'll say, well, we'd like to, but we can't because it doesn't guarantee no exceptions are thrown. But if I did put that, it's like, oh great, I can still use it. And we know we don't throw exceptions from our move constructors because that just transfers ownership of a unique pointer. That never throws exceptions. And the same thing, oh, how come I'm missing it? Same thing for a destructor. Destructor it'd just be absurd to throw an exception from a destructor. So we just never do it. So we tell the compiler, guaranteed no exceptions are thrown from our destructors. And that it's really just helping out the compiler. It enables the compiler to do a little bit better optimization. I'm just going to do an amend. So add dot git commit amend. Oh, it popped up. It popped this up. There's got to be an option to tell it not to pop it up, but I don't know what it is. Actually, let me look that up now. Git help commit. Just because I'm curious. What if we wanted to commit without popping something up? Is it just -A? Automatically adds files, and then perform the actual commit. Let me test this. So, if I just say -A, no, it still pops up an editor. How do we tell it we don't need it? And why do I have 2 Twitch windows open? I don't know. Mysteries of the universe. So, git, oh, what am I doing? Git help commit. I'd closed the window and I didn't mean to. How do you tell it you don't want it to be interactive? Okay, no, it's not that it's interactive. Is it just the M? Mutually exclusive with C, C, and F. Okay, I really want to figure this out. How do you do commit, amend without prompting, without editing message? I want to know this now. Must no edit. Okay, let's try that. No edit. Ah, there we go. I gotta add that to the notebook. I hate being prompted when I don't need to be. Tip of the day. Git commit amend no edit. Just amends the last commit without the silly editor prompt to edit the commit message. Yeah. It was just annoying me that it kept popping up Notepad. I'm like, I don't need to change the commit message. Okay. So we just did that, which was cross-cutting a lot of things. I guess next is collect together and refactor various functions which parse integers. Yeah, so actually, where was that? It was where we do this multiply equal to 10. So Rally Monkey, I don't know if you saw this, but yesterday I put in this better check for overflow that I was talking to Gremlin offline about. This is actually at the secure coding class that I've seen was required at my last job. They said this is the most correct way to check for overflow, is you do this check before you do the potentially overflowing operation. It's if you write down the equation, number times 10 plus the digit, is it greater than the max? And then you just solve it, you just restructure the equation so that you make sure the number is on it by itself on one end. You get if max is minus a digit divided by 10 is less than number. That tells you if it's going to overflow. So you can do the check without actually doing the overflow and just bail before it would have overflowed. So that's what I've been told is the technically correct way to detect overflow. And then I had a viewer suggest that you can even avoid this check altogether to make it even more optimized. If you know the length of the string is less than the length of that the string would be if it was the max, then you don't need to check at all. And also, if the length of number string is greater than the length of the max as a string, you can return false right away, saying you definitely would overflow. I don't even need to process the string at all. Most correct because it doesn't actually overflow, because you could argue that the behavior is not completely specified depending on the type. I think if it was like a signed integer, overflow, it's either overflow or underflow, is technically not specified by the standard, so it's up to the implementation. It's one of those like gray areas where it's better to just avoid the overflow in the first place if you can, and this is no more and no less efficient than what I had before. It's just maybe a little bit better. It avoids implementation details. Okay. So yeah, these places where we're doing this multiplication, I think we can move out. Except for this one. This is buried inside of a state machine. Because this one handles negative numbers. Actually, maybe we could pull this out too. We could, and we can just after this parse size. This is called within a context of it has to be a positive number or non-negative. We could use this function and just if we get a negative number, we can just reject it. So we have two copies here definitely. They're exactly the same. Well, almost. One gives more information than the other. So we could combine those two. And it looks like URI has its own version of it. Ah, and this is not even, this is using the old overflow check. Oh, and this is also using the old overflow check. Let's put in the correct overflow check here first. Then we'll think about combining it. So this is the correct check. That would go here. We don't need previous value anymore. Value is an int. This is digit. And then instead of number, it's value. And then it's just return if it would have overflowed. Digit. There we go. Static numeric limits is declared in limit. Limits, I think, yeah. And I think here I can take advantage of doing decal type value to be extra, what do you say, extra cool, because then now this code doesn't even need to change if we change the type of value. Oh, hey there, Ubi. How's it going? How was your interview with Microsoft? Oh, nice. Does that mean you're gonna have to move, or you get to work from home? You don't have to say if it's too much personal information. Just if you want to. That's cool though. It's exciting. You got an interview and you got an offer. It's always cool. Okay, we didn't fail any of our tests. I always like to see that when I'm refactoring, that nothing broke. Yeah, I wonder if I could just start using command line git. It's maybe a little bit faster. Because what it's commit -a -m. Oh, you can't hear me? So let me type it. That's awesome. It's always nice to hear when someone gets an offer, an interview gets an offer. In an airplane right now. PogChamp. Congrats. Good luck. Santa Barbara. Awesome. Yep. Yep. Closer indeed. Same time zone. For some reason, Siri thought I was talking to her. Okay. I'm going to commit this as put in more correct overflow check. Okay, so yeah, so this is more technically correct. And I believe, okay, it's operating on code points though. And this is operating on a string. Is this technically better because, no, it's not. It doesn't really need to handle anything else other than ASCII. So where's this? What's the context of decode as integer? From encoding. I should say, have a safe flight. Terminator. Is that my new nickname? That's a Terminator. I terminate the code. Okay. Decode as integer. Yeah, I don't want to have to re-encode it as ASCII. Maybe I'll leave that as a special case. Hold on, I lost my search. I'm tempted to leave this there and just collapse HTTP client, HTTP server, and URI parsing of integers. Yeah, so let's do that. So what would be a good home for that? I've kind of been piling things into system abstractions if it's a utility. Does that really make sense? I suppose you could say I'm abstracting the utilities of the system. So what would I make this a new? Make it actually it's manipulating strings. So let's make a part of string extensions tests. we'll call this not parse. I don't like parse. From string to int. How about to integer? I like that. So I'm wondering, do I have any tests for this at all? Okay, let's look in URI tests to see if there are any tests about that. Collapse this down. Parse from string. Okay, I think here were some. Yeah. But that's specifically for 16-bit integers. Okay, and then I think this HTTP tests in the server. I'm being shortchanged by at least 3 people. Oh, because you have people physically present in the same room watching? I guess you could have them log in on their phones or something. I'm wondering if I'm getting fewer view count because they count it differently once you get to affiliate status, and they stop counting like the bots. I think I have 3 bots at least watching right now. Yeah, my favorite viewer, Decaf Smurf, is on. Okay, I was looking for tests that deal with integers that aren't parsed right. It's like this overflow, right? Overflowing content length. Yeah, so that's indirectly testing things. We could throw that in as one of our first tests. So expect. Do we want to keep the same convention? I think it was server that did this. Had this parse size result. Maybe. Yeah, let's bring that in. So expect system abstractions. Okay, what do we kind of call it? Decode. How about to integer result? And then we'll just have the same convention. So overflow. Actually, let's do the whole test vector thing. So struct test vector, and then we'll have vector, the const vector of test vectors. Declare it like that, and the first thing will be, well, the first thing will be the string input, and the next one will be the expected result. And then, well, I guess we also want the output. And we should, let's just use one of these neato types. Int max t. I don't get to use that as much. Hi there, not Zane. I can disable some bots, but the bots are my friends, right? They don't do anything bad, do they? They probably just stick around hoping to get loyalty points. Maybe I'll grant them loyalty points someday. Who knows? Okay, so general pattern here for const auto test vector and test vectors, and then we can expect the test vector dot expected result. Okay, it doesn't want to autocomplete because that type doesn't exist yet. Let's make room for our output. System abstractions to integer test vector dot input. Grant them moderator status. I'm not. I don't want to have a death wish. Death wish? I don't have a death wish. Okay. Let's define some test vectors. So we had our favorite overflow somewhere around here, right? Yeah, this one. That'll overflow probably on every machine made until I'm long gone. So the output will be, doesn't matter. The expected result will be overflow. Let's put some sane ones in there, like 0, success, and I don't know, 42, because why not? And I'll have minus 42 in there, negative 42. And let's test up to the numeric limit of int max t. Actually, I don't need standard, do I? Because that's a C type. Max. I just need to put that back into a string, so system abstractions printf percent pri. Oh, for that I need int types. And while we're here, we'll include limits. Pri d. Do they have a d max? Yes, they do. What is that on my system? 64-bit. Okay. Okay, that's a little too long, so we'll break it up. Break that thing up. Okay. And then we want to do the max plus, well, can't do the max plus 1, can I? Actually, what I can do is I can take this max here. So I just maybe add a digit. And then I don't care what I get back. That's going to be an overflow. I also want to test the min. And that again with one extra digit. Where it doesn't really matter. And it's an overflow. Or underflow, whatever. Okay. Okay, in addition, if the yeah, let's say if is that read right? I'll do that. You don't strictly need to do that, but it helps me and read it. Expect equal test vector dot output matches the output. Okay, so it really doesn't like that this type doesn't exist. Let's move it from server. And go ahead and we'll go ahead and cut it from there and go to system abstractions and paste it in the header file. Excuse me, header file. String extensions. We'll just put it alongside the function that's going to use it. These are different results that can be indicated when a string is parsed as an integer. To int integer result. That should quiet this down. Oh, that's okay. That's right. It's not simply true. It's this whole enumerated value enumeration. What do you call it? Enumerated type value? I need a shorter word for that. Okay. So we just need to make the two integer. So we'll copy the documentation and the declaration to right here. So it's just going to be 2 integer. And we'll use int max T. Okay. So much for low latency mode. It's still like a 15-second delay going on. And no, I want standard int. And it goes there. Okay, parses the given string as an integer, detecting invalid characters overflow, etc. Well, number, sure. Where to store the number, yes. Yes, okay. So it's a neighbor to 2 lower, so we'll put it near 2 lower. And then the body of it. We renamed this enumerated type. And let's see. I guess this should just be int max, shouldn't it? I need to be careful though. I don't... What am I saying? I don't want to accidentally sign extend, but this won't because it'll just be from 0 to 9. So that should be fine. This though, I want decal type of digit. There, that'll work. I was going to use number, but I have problems when it's a reference. Like if I tried that, if I tried this, it probably would not like it. Yeah, see, it doesn't like it. It thinks I'm using an initializer list of some kind. But if I say digit, which is not a reference, then it's fine with it. Whatever. Okay. Tests are good now, right? Inputs. Input. Okay. Alright, we're getting there. So, system abstractions test debug. I have a feeling that my neighbors are about to use a jackhammer. I'm gonna have to close my window. Oh, yeah, this got removed. Maybe I shouldn't have cut it from where it was. I'll just leave it, just so I can build the test. Then we'll cut that along with the function and the thing that uses it. Oops. Running the wrong tests. Actually, I wonder if that jackhammer outside will get picked up by my mic. I have to... My test will be when I'm not talking, does the mic get triggered? Okay, they're not doing it regularly, so it's hard to test. Okay, what's going on here? It should have converted it. The mic is picking it up. Oh, it's not handling negative numbers. Yeah, so did the client? The client didn't handle negative numbers, but the was it URI? One of these? Did? No, that didn't either. JSON, right? It handled negative numbers? So maybe I should grab this as the implementation. It just doesn't deal with the code points thing, so we'll have to turn it around. Well, let's see. Let's see if I can use it. I think I can, I just have to return the right things. So, here. Return that. it's not a number if we aren't in state 2. Or what? Yes. It's not a number if we're not in the right state. We don't need a type. I'm not gonna do this stuff. Am I? No, I'll do that. So this will be number. I just need value to be an int max t. Code points becomes this. It looks a little nicer. It's essentially the same code, only it handles the leading 0 and the minus correctly. Alright. I need to return overflow in the correct place. And then extra junk is not a number. There we go. So I think we can use that code instead. Oh, where did I forget a return? Or there I did. Okay, that's not a number. Okay, what's wrong? gtest filter equals to integer. Oh, it didn't handle the negative correctly? That's for the large. Is that the largest number for 63 bits? I don't remember. What is 2 to the power of 63? Oh, I guess it is. Interesting. So it handled negative 42, but it didn't handle the min value? Let's see that in action. So, system abstractions test. Here you are. Set a startup project and set the breakpoint, I guess right here, and then we'll just go till we get to that vector. There it is. So we'll step in. So go to there. Oh, it broke out. Oh, okay, I see what happened. I did not notice this part. It's basically saying expected success or 0, whichever. Where is it? Expected success got overflow, so it thinks it overflowed. Oh, I know why. Okay, I was being dumb. So in the overflow check, this is assuming that, yeah, this is assuming the max. For 2's complement numbers, you can have one less. The magnitude could be 1 greater for the negative numbers than for positive numbers because of 2's complement math, right? So how do I do this math then? I would do it if this is not negative. If negative, do one kind of check, and positive do another kind. So negative, we're going to be doing the min. Plus the digit. divided by 10, correct? Is less than the negative of the value? Because we're building the number as a positive number. This will flip it to negative, and we're going to be comparing it to the largest magnitude that it can be without overflowing. Actually, this is going to have a problem anyway, isn't it? I can't flip it to negative here at the end. Okay, I think what I really need to do is flip it to negative in state 1. And then I don't need the negative flag anymore. So get rid of this. And it'll be in state 1. It will be this. Then we don't need the negative flag anymore. Actually, we still use it here. It's just I don't need to do that anymore. And this is different, right? If negative, we would subtract the digit. I think that's right. Nope. It went horribly wrong. Okay, that looks strange, like it's not initialized or something. Why is it int? Well, can we do this? Does it let me do that? I guess it does. Okay. But I still don't have it. It's still completely broken. Yeah, there's something really wrong with this. Oh, I know what it is. Number equals value. It's just not getting initialized, or not getting set at the output. Okay, we're getting there. It's just that the negative numbers aren't right. So, if we find that minus sign, it's supposed to set negative to true. Then the next digit, in the case of like minus 42, it should have been set it to 4, and then initially it should have made it a negative number. So what did it do? Why didn't it make it? Okay, I'm gonna see. Try this again. Okay, here, negative 42. It's negative, yes. Let me watch autos here. 4. Now it's negative 4, yes. Digit is 2. Oh. Oh, I think this needs to be greater than, not less than, because the sign is flipped. What's this? PDB error? Unexpected PDB error. Okay, some kind of transient problem. There we go. So as long as I tested the corner cases well enough, which I think I didn't quite. I just added a 0 onto the end. What I really want to do is increment that last digit if it's not a 9. Is that easy to do? I guess it's not too hard. So we would take this and put it here. We'll call this one max as string. And the other one min as string. And that's the min. It will say, well, actually I can see it on the, well, no, I don't want to assume. Yeah. I want to add one. This is tough. Add one. It's easy if the last digit's not a 9. If it's a 9, then you have to set it to 0 and then add the next digit up. And so that could continue. And you could end up inserting, well, it's not too much to worry about. We'll just do it here. So auto max plus 1 as string equals max as string. Size t digit equals max plus 1 as string dot length minus 1. And we'll say while digit is greater than 0. Okay, let's say we'll start at length. So it's 1 to the right of the digit. But if we get to 0, then actually we'll say if we get to 0, then we're going to add a 1 in front. So if max plus 1 is string digit minus 1 equals a 9, else if it's a 9, we got to set it to 0 and then continue, right? Otherwise, we're going to add 1 to it and break. If digit equals 0, like that. If digit equals 0, then max plus 1 a string, insert. Okay, max plus 1 a string dot begin, 1. Let's make this a function, because I'm going to use it twice, right? Well, no. I'm not going to use it. The other way it's, okay, yeah, it's a little bit different. Min minus 1 is min as string. And here it'll be 1 greater than 1. We're going to insert it because it's right past the minus, right? Okay. So then I can say this is just max as string. This one is just min as string. Right here. This is max plus 1 as string. And this is min minus 1 as string. Actually, I'm going to remove this case, as much as I like it, but the corner cases are good enough. Okay, I did redefine digit, didn't I? Let me step through this to make sure it's doing what I expect. Okay, 42 minus 42. There's the max, there's the min, there's the max plus 1, so that ends in 808, which is right. And the min minus 1 is 809. Cool. And that passes, right? Alright. So I feel a lot better that it's catching that corner case. The corner case between overflowing and success is just adding or subtracting 1 from the very limit. So I'm going to check this in. Yep. Git commit add to integer function. And I didn't change anything else, did I? Nope. Got a lot of things to push upstream, though. Kind of second guessing my earlier decision not to push them upstream. Just do them all right now. I'll queue them up to happen. And, oop. Syntax error there. I'm like racing Git at this point. I won. Yeah, pushing to GitHub is a little bit slow, but I guess I really shouldn't wait. I should just do it when I first make the commit. That way I don't forget to do it, and it's not a big pain later. I suppose I could build in a mugget command to do a mass push. I have a mass pull. I don't have a mugget push though. That might that I could actually use that. Let me make a note for that. Idea mugget push to have one mass push at the end of each stream. Alright. So I have now this to integer which handles any size integer that the machine can handle, and let's use it instead of the custom ones here in server and client. So it's this parse size thing, right? Parse size. So we will have content length as int max t. System abstractions to integer, and that's yep, okay. Content length as string, as int. And this is this to integer result. And then I'll do let's say if content length is less than 0, it's an error, right? Oh, and then we got to return message end, right? And then we will say size t, or auto, const auto content length equals convert to size t, that content length is an integer. Let's do this actually. No. This will always be a size t, so it's not greater than the maximum. Actually, I prefer to do that check first. And make this a size int max t. Oh, actually, you know what I'll do? I'll make this of that type. That's what I'll do. Just so that I don't have to do typecasts, which might truncate. Let's put a note here. This is the maximum allowed. Make sure this is never larger than the largest value for the size t type. I mean, it should never be the case, but we are doing a conversion from int max to potentially down to size t, which is allowed to be smaller, I suppose. It could be bigger because it's unsigned. As long as that guarantee holds, then this does not truncate by accident. And we'll be good. Okay, so that should be good for server, and then we use the same stuff in client. So let's do that. Let's go next. Client. It's got its own parse size thing here. Remove that, and we're going to include system abstractions string extensions. Okay, status code as int max t. System abstractions to integer. So just put that there, and then we have to say if it's not equal to system abstractions to integer result success. Since there's more than one return possibility. And that's there. There we go. That works. Oh, I guess I call it twice. So content length as int first. Int max t. System abstractions to int. Okay, let's break this up so it does not get too wide. And it is as int and then not equal to, again, the same thing. Result success. Right, so max content length is what? It's what we have already received. So it can never, well, hold on. It's never going to be really that big. So if I convert it to int max t, it's probably safe, right? And then do that as int. Similarly, I should be able to actually use that there, right? Will it give me a warning? But technically I need to convert it down, potentially down to a size t. I should check if it's less than 0, though. Actually, what we'll do is just say const auto content length equals size t of content length as int. Then I can put this back to where it was. There we go. All right. This was all in HTTP tests, right? So we're all good. URI was next, right? URI had a copy of this thing. Yeah, parse uint16. So get rid of that. It's already using string extensions. So this is system abstractions to int if that is not equal to success. And then we need to say port as int. I'll say if port as int is less than 0, or port as int is greater than standard numeric limits of uint16t max. Return false. For numeric limits, I need limits. And what type is that? Okay, so let's convert it to int max t. And then if it's not, then port equals the uint16. Well, hold on. We can be a little bit more sophisticated as that, right? We can say it's decal type of port. And I can use the same thing here. And I can actually use that same trick here. For some reason, I really like not having to repeat the actual concrete type. So now if I change this to something else, like int, okay, it doesn't like it here because it does actually wants an int max t, but otherwise the code remains unchanged. Alright. There was one more, it was in JSON, right? Now can we actually use it here for JSON? I think the only difference is this decode as integer takes Unicode code points and not characters. I suppose if we're willing to take the hit of converting it back to a string, then we'll be good. Let me see if we actually have the original string. Encoding. I guess we don't, do we? What was that encoding before trim? Oh, you know what? Here are some functions we could also pull out, right? Well, no, these are specific to Unicode code points, so never mind. Actually, I think I know what I'm going to do. I'll take the hit, and I'll convert that back. So that's, what is it, const, or UTF-8, UTF-8, and it's encoder, const auto s equals encoder dot encode the code points. And then we set it to type integer if it succeeds. So if, well, int max t value, right? If system abstractions to integer s to value is not equal to success, we'll bail early. This code just returns early, right? Yeah, okay, so how come it doesn't like, oh, it's, it wants a string here. Standard string s.begin to s.end. There we go. It could also overflow value. Oh, it's int. Is that integer value is an int? Okay, so yeah. We should do that check. So if it's going to be both positive and negative. If value is less than converted to decal type value. Standard numeric limits of decal type integer value. Min. Or it's greater than the max. Then return. Otherwise, we can do this. Right, decal type integer value. So just run the JSON tests. Cool. Let me run all the tests. I think we'll be done because that's all of the places where we're converting strings into integers. What is this one? Octet string. And this is sort of a very narrow subset of that to integer. I think I'll leave it. So we're all good. So just JSON that we changed? Oh, no. Oh, it was all of them, yeah. Something decidedly non-doggo in the background a moment ago. Yeah. So, did you hear someone being yelled at? Ignore the people behind the curtain. What was that $9.99 I saw? Yeah, okay. So these are all related. So this is git commit, all with a message of use system abstractions to integer to convert strings to integers. Same thing. URI. I should have known that one. My brain is not holding these short lists of things I need to push. I'm depending too much on the computer to remember for me. Okay, we should be good, and I can move on to the next thing on the list. Alright, replacing this. I'm going to do a little bit of this. There's a lot to do, and it's a bit tedious. I'll do a little about this. And then move on to handling clean breaking of connections last. Fixed width for my brain. Yeah. Okay. Chatroom plugin tests. So I remember this. We were working on this yesterday, but it's a pretty tedious thing where everywhere that I'm doing set, all these places, I wanted to make it use the new factory method. Factory method looks like this. If this is what it looked like before, the new one is this. Message equals JSON object, where you can just say type get nicknames. So it looks more like a JSON object. Looks like that. It's a little bit better, for example, like this, where there's three sets in a row. We can just do this. Doggo barking. We have a guest. Okay, that replaces that. Yeah, same thing here. Yes, this gets a bit tedious, so I'm not gonna do a whole lot of it. Just do a little bit each stream. Maybe I'll do this off stream since it's so tedious. Expected response join nickname Alice. And then response 2 is a set nickname result success true. Okay, I think I don't use auto here because we're just reusing it. Same thing with message, right? Wonder why I'm not getting a little red squiggly to warn me about that. Message, get nicknames, expected response. Okay, no auto. Sending a tell in this one. Expected response has this extra thing in it. Okay, getting there. Auto. Actually, I think I'll just do this last test here, and then I think I'll just do this off stream since it's a bit. I think I've shown enough of this. There's really no need for me to stream the rest of this stuff. Yeah, I should make like a general rule that if something gets a little bit too repetitive and tedious, only stream a little bit of it and then do the rest off stream later. But let me just finish up this one test here. Just one. And finally, sir, you wafer thin mint. Riley Monkey knows what I'm referencing there. Okay. Almost done, I promise. Then we'll get to something a little bit more interesting, hopefully. Alright, we'll cut it there. I'll do the rest of that off stream. Let me make a note. So, do the rest of the JSON set, JSON object stuff off stream. And run the tests, please. And I'm going to assume that they're working right now. Just to get us set up to check that in. Okay. Web server, yes. Oh, we'll run the GUI. Yeah. I feel like running the GUI this time. So Chatroom plugin. Replace more JSON set with JSON object calls. Alright, so the final thing I had on the plan this is a class that abstracts the differences between Windows, Linux, and Mac and all that for making network connections. So if there's a method to tell it to close a connection and it does an abrupt, or what do they call it, abnormal close, where if you had written something and it hadn't yet been transmitted, it'll get lost. So the idea is we're going to add a way of closing it that doesn't immediately close it until it waits to close it until all the data's been sent. If that makes sense. And I think along with that we're going to want, so two things. So delay actual close until all data queued to be sent has been sent. And then we also want to notify the peer that no more data will be sent. And then wait a reasonable amount of time. Or does it really matter? I might have to do some research on that. I was going to say wait a reasonable amount of time for the peer to close their end, but I don't think we need to wait for that. I think the OS takes care of that for us. So this notifying the peer that no more data will be sent is part of the handshake in TCP. It's called a fin token. FIN for final. And that's kind of how you let them know that they can stop reading the socket because no more data will be sent. So we should do that. And I believe that the way it's done in both WebSockets and in BSD sockets is through the shutdown. So it's called a shutdown function. Shutdown part of a full duplex connection. It talks about it somewhere in here, I thought. Okay, maybe not. Maybe it was the WinSock description that talked about it better. Where would I find that? MSDN? Or no, here we go. Shutdown function. Right here. If how is SD send, subsequent calls to send function is allowed for TCP sockets, a fin will be sent after all data is sent and acknowledged by the receiver. And it says to assure that all data is sent and received in a closed socket, connected socket before it's closed, an application should call shutdown to close the connection before calling close socket. Right now we're calling close socket and not calling shutdown first. It talks about one way to wait until the other side has sent all of its data is to wait for FD close. I don't think we need to do that. Okay, I'm just reading through to make sure I understand what's going on. I think what we just want to do is call call shutdown and then call close. Hold on. It says any resources attached to socket will not be free until close socket's invoked. Maybe we have to wait before calling close socket. Or there was an option with linger, right? We talked about graceful shutdown. Here we go. Need to make sure I follow this. Yeah, see, no wonder. It says some amount of confusion arises. Yeah. So I'm part of that confusion, apparently. So an abortive shutdown sequence is to immediately return from close socket. So it's talking about delaying return. So maybe the way it is we set up the socket option. We call shutdown and then call close, and it just blocks, which is okay because we'll do it from our processor thread. We have a separate worker thread that does the reading and the writing of the data on the network connection. We can have it do the close and allow it to delay return. Okay, yeah. Let me read through this. Invoke shutdown. Okay, so it talks about waiting until you receive FD close. Maybe we'll do that. So we'll make sure that we're receiving FD close. So we'll call shutdown immediately and mark that it should wait for FD close. And if it receives an FD close, it will then call close socket. And on the server side, what happens? We receive one. Okay, send any remaining. Invoke shutdown. Okay, and then we just immediately close. So it depends on which happens first. If we're the first to close, we'll do a shutdown. Wait until we receive FD close and then call close socket. If we receive FD close first, yeah, right. We'll wait until, I guess in either case, we'll wait until all the data has been sent, right? If the graceful shutdown is indicated. And then we'll call shutdown and immediately call close afterwards. Yeah. Okay, that sounds good to me. We just have to make sure I think we might already be waiting for FD close. Let's look. Close all this stuff. How are we with the check-ins? All our tests are passing. Everything's checked in. Okay, good. So, clean workspace here. Let's set up a test to test this. Bark, bark, bark. I'm gonna I had to put the dog in the backyard for timeout. And some outside time would do her good anyway. Let's see. Yeah. Well, if you see that overlay, that's part of the reason it's there. To let you know that it's just me muting. Okay. I don't really have any tests specifically testing closing, do I? Oh, I'm not even looking at the right unit test, duh. Stupid. I'm being stupid today. Network connection test is what I care about. Okay, I do have a close during, okay, what's the close do? So we open it, the server, we open the server, connect with the client. What are we doing here? Waiting for the client. Okay, we're waiting for the server to put the client in its client list. We assert that the connection wasn't detected to be broken at the server end. We close it from the client end. And we wait for it to be disconnected at the server end. Okay. Oh, background noise? Yeah. Not sure what I could do about that. I guess I could put like a little like a little sound pre-recorded sound on a loop, some kind of a intermission sound, like they have on Mighty Python, something like that. Let me make a note about that. During my commute, consider some replacement background music, some kind of on a loop, so it just doesn't go dead silent. Okay. So this is sort of a graceful close. It's not really. We want to really. We have two cases, right? We want to have an abrupt close where one end just really hasn't even read the data yet and just gets abruptly closed, and the other one we want it to be graceful. So let's work on that. What's client using? Hold on, it's using a network connection to test a network connection? I'm not sure I like that. I thought this had some like manual socket stuff in it. Or was that we're using network endpoint to test network connection? Network endpoint test had raw socket stuff. How do I want to handle this? Well, let's see. What kind of test do we have here? Connection broken. You want me to play it now? Let's see what it is. Yeah, that's exactly what I was thinking of using. Yeah, that's what I was thinking of using. Thanks for looking that up for me. Okay. I guess we could test here. It's sort of indirectly testing network connection, though. You know, I feel better about actually pulling in some of this. This is like the gunk that you actually have inside a network connection, but how do you test a network connection without having another side of it? Yeah, just thinking, sorry. How am I gonna do this? Oh, okay. Hold on. Maybe it was a network endpoint thing. Where is that? Libraries, system abstractions, network endpoint. And then network connection, right? Okay, neither one has the method. Hold on, I'll be right back. Cue intermission music. Okay, back. Yeah, I think I'm gonna bite the bullet and take some of this raw socket code from network endpoint tests and copy it to network connection tests up here. Scanning, scanning, scanning. Yeah, we had the fixture do that setup for us, so let's copy it here. How many tests do I have here? Not that many. Okay, fine. We'll make the fixture same kind of fixture. Right. It's just making sure for Windows that we start up Windows Socket architecture, wherever the A stands for, and then we clean it up when we're done. It doesn't hurt to do it for all these tests. What I really needed is for the next test. It will be close graceful. Or hold on. This one up here, it doesn't really matter. It's just checking the basic machinery. Maybe we'll get rid of this one, this original close, and we'll replace it with two here. Close gracefully, and then close abruptly. Yeah, so I guess we need to set up a server-side socket, right? So connection receiving? Connection sending? It doesn't really matter, does it? It's all this gunk. Set up a connection related socket to test, well, to receive a connection from the unit under test. So we'll call this server. Server address. Doesn't matter what port we get. What's it have here at the bind? Oh, I copied the wrong thing. Server. There we go. Okay, all that to get the address and port number. Well, okay, I guess we're not really done, because we want to do assert to listen server. What does the network endpoint do about the backlog thing? Is there like a default that it does? Listen. Oh, SO max connection. Fine. Do the same thing. And then it's 0 on success, right? And then after listen, we do, I think we do a accept, or we have to actually wait, don't we? Hold on, let me see if I can I just call accept and it'll block? Accept. Okay. Okay, it's only if it's non-blocking. We're not making it non-blocking, so we can just cut this to an accept, right? So we will connect. Have unit under test connect to the server. And I think I can copy some of this stuff, right? This thing. Okay, I don't have a client, do I? Client is a network connection. That's the unit under test. And the bound port is, I guess we can just call that server port, right? Server port. And then we'll assert true. What does accept return? Oh, it returns a socket. So const auto server client? Server client? Is that going to be confusing? Server client, a server client? How about server connection? Equals, that's accept. And it takes the server socket. Okay, it needs an address and a length again. So let's make one. This is the client address. And we need an address length. Yes, one of these. Client address length. Client address, and that's going to be an address of it, isn't it? And it needs to be typecast to struct sock address pointer. And then not size of it needs an address. Client address length. And then we'll assert that not equal to, what does it return on error? Invalid socket. Ooh, okay, I guess we need this thing. It's not really that clean of a test because after we've bound, if some of these fail, well, we won't have closed that server socket, will we? Actually, it's this. Actually, you know what I'll do? I will make a shared pointer to a socket. Is that the type? Do we have a type? Do I have a type diff for that? I do not. How about I will define socket in here to be int, and then I'll just use socket. So that's socket here. Server reference. I'll just take advantage of the RAII of a standard shared pointer. So the resource will be just the server, but the it wants a pointer, doesn't it? Okay, address of, why not? And why doesn't it like that? I don't know. I think it just needs me. It needs me to give it a deleter. This is the whole point of doing this. It was socket s. It doesn't really matter here because I simply close socket that abstracted away? I don't have that abstracted away, do I? Am I not closing the sockets in the other test too? I don't. How sloppy of me. I create the socket sender one and all that, and I use it, but I don't destroy it when I'm done. I should. Oh well. Close socket is just close on POSIX. Anyway, let's just say close server. I guess I'll capture it. Because I don't really need this S. I don't even really know if this pointer is the right, is still in scope, so I'm not going to use it. This is just to make sure I automatically call this when the test returns. I think it's all the real cleanup we need to worry about. Okay. So assert was actually what I put in here. So it's connected to the server at that point. Then for a graceful close, I guess what we'll do is we will queue up some data and then tell it to gracefully close, and then we'll assert that it doesn't break right away, not until the client has closed their end, right? Yeah, so it's going to be tough though, because the processor thread for the network connection, it's in its own thread, and I really can't tell it to slow down. I guess it doesn't really matter if we send data or not. I suppose we could send an enormous amount of data and just count the number of characters we receive on the client end, or on the server connection end. Well, yeah, let's try that. So queue up to send a large amount of data to the server. So hold on, that would be, we're going to be doing client dot send message, some large vector, so data. And that's, it doesn't really matter what the data is. What constructor takes a value and a size. Count, and then what is that standard out? No, that's not what I want. Count and then value, there we go. So, I don't know, a billion X's? Maybe that's too big. How about 10 megabytes? I want to send enough data to pretty much guarantee that it won't all be received before I tell it to close. Issue a graceful close on the client. And here's where I want to be passing an argument. So I think where was it where we used this close graceful? Was it I can't remember what it was. It was in like HTTP somewhere, right? Or HTTP network transport? One of these. Maybe it was here. Clean, that's what I called it. So we'll call this one clean as well. So verify server connection is not yet broken by receiving all the datas is not broken until all the data is received. So it'll be, let's have a count. Bytes received. And buffer. Let's have it receive in small chunks, like 100,000. I got a delivery of Yogurtland. Isn't that nice? Okay, while bytes received is less than data.length. Or really, you should use size for vectors. Okay, here's where I gotta remember, how do you talk to a socket directly? We'll cheat and we'll look at network connection. So how come it's not in my editor? Actually, don't I have some of it here? Like, there's like a send, right? I guess not. Actually, we can, I think by default it blocks anyway, right? And we're receiving, not sending. So it's receive, right? Const auto. Let's make this total, because I want to use that name. Bytes received. Bytes received equals receive server connection buffer, so it's buffer.datas. It wants a char star, okay, fine. Length as an int. This is getting too long. Split it up. And the flags. Well, what flags do we want to send? Receive. Where are you? Receive. Flags. Okay, let's do this. Message wait all. I guess I should just check if that's in POSIX too. POSIX receive. Is it in POSIX? I guess it is. Okay, it is. The wait all is defined there. Alright, so that's good. So wait all. Total. Oh. Actually, we need to compute something, right? Bytes to receive. It's going to be the minimum of 2 numbers. And for min, we need algorithm. It's the minimum of the buffer size. And then the size, the data dot size minus the total bytes received. And that's how much we'll ask for. And then we'll add, well, hold on, not add, because we get -1 on an error, right? And we get a 0 for a shutdown, apparently. What does Windows say for the result? If the connection has been gracefully closed, it's 0. Okay, so socket error. What's socket error? If bytes recede equals what? I just want to see what is socket error. Is it a -1? Yeah, okay, it's -1. So basically, if it's less than or equal to 0, then well, we can assert that this is not true. Total bytes received plus equals bytes recede. And we loop, right? And then furthermore, we want the client not to have indicated that. Oh, hold on, I missed something. There's a right. Here's where I missed. In process, we give it the callbacks that we want. Where did I do? Did I forget to do the connect? Oh, I have the connect there. Okay. Yeah. So actually, I wonder if this will block and I wonder if we'll get into a deadlock because those one blocks, right, and the other one needs to happen before the other one can return. Yeah, I think actually this is going to be a problem because I need to run this code here on another thread, and this connect here is going to block waiting for it. So ghetto style threads maybe. We need to do this first. Put this in a thread. So it would be something like this. Standard thread. Call server accept. And then it needs something to call. So we'll just do this. And let's capture server. Yeah, okay, so because accept blocks, right? Okay. I guess we don't need this stuff that we had before. Why did I have that anyway? Owner. Oh, because it had stuff we could like wait for things on. Actually, I think that's because we used to not use delegates. It used to need an object. And so I had to make an object called owner. Yeah, so what I really care about here is like a broken flag. Initialized to false, and we capture it here by reference, and we just set it to true. So verify client or unit under test has not yet. Well, does it really matter? I guess so. It has not yet indicated that the connection is broken. Assert false, broken. And then finally, close the server connection Verify the connection is finally broken. And we'll need to do a wait actually. So I have all the things I need for that. Actually, it's already built into this owner thing, isn't it? Await disconnection. Okay, yeah, so maybe I will use that owner thing. What's this connection broken delegate? Is that something extra I could call? Okay, it is, yeah. So let's use that object since it has what I need. All right. Here it is. Yeah, we need it up here. This stuff. So this down here, where is it? Eh? Why does it say server connection is not defined? Oh, it's not. Well, let's fix that. That's a socket. Server connection. We will capture a reference to it here and do that. And let's join the thread here to make sure it happens. So that's server accept join. Where is this broken? Okay, we're removing that flag. It's this dot connection broken. Because right now what I want to do is say close socket server connection. I don't care what it returns, but I will say assert true client owner dot await disconnection. There we go. Okay, time to add that flag. I'm going to copy the meaning of this flag from where I had it before in HTTP connection. This method breaks the connection to the peer, either immediately or not. Let's have it default to the old behavior. Yeah, let's do that. Oh, wrong place. Oh no, that is the right place. Oh, we already had it in the implementation, I guess. Okay, we say immediately break. Maybe we want to copy what we had before. Not what we had before, I mean, maybe this flag. We also have the stop processing flag. Is it one and the same? No, it's not. The stop processing was special, I think. Well, hold on. Let me verify. So it's wherever this close is called. Wait a minute. I thought it was okay. That's right. There's two different files. Here's the second one. It's wherever it's false. So it's false when it's called. Right, because we haven't started the processing yet. And from the processor itself, you don't want to call it. So those flags do mean something different. So we'll keep stop processing first, and we'll add it second. This flag indicates whether or not the processor thread should be joined before closing the connection. Okay, and then go to here. Let's make that also the default behavior of false. Put that there. Okay. Right, it's this close socket here. So basically, if clean, then we're going to do something else. For now, just to make everything build, we'll say to do. Describe what we're going to want to actually do. Change this to mark that we want to automatically close once all data has been sent and we have received back the in this case it's window, so it's fd close signal. Is it called signal? Let's see. I don't remember. Okay, they call it indication from the socket. But right now we'll just do exactly the same thing that a non-clean close does. And pass along that clean flag. Alright, so system abstraction tests. I will use a filter just so that we run the test we've been working on. Close gracefully. Okay, we appear to have a deadlock. Oh, no we don't, it just timed out. $7.80. Huh. Okay. I didn't expect that to happen. Let's have it print out the total bytes received. Huh. So it received 64 kilobytes and then kind of blocked. I'm kind of curious why, so let's set this just to run our one test. Close gracefully. Have it run and then I'll hit a break while after it's stuck for a while. Break. Huh. So it got almost 8 million bytes into it. Is the processor thread just not running? Let's see. What's the thread doing? Okay, that's weird. Because shouldn't it have stuff to do? So, hold on. This platform pointer. Go back to. Actually, it's not in hexadecimal. Yeah, the output queue, it's got a lot of stuff in it, a lot of X's. Why is it not running though? Hmm. It's supposed to set this processor state change event, which is what this is one of the things that this one's waiting on. Is it not actually running? Let's see if I hit go. No, it's still stuck there. Very weird. Oh, hold on. Maybe it was because it was closed. Let me retry this. Okay, main thread is still sending. Oh, it's doing it in one huge send. That might be why. Actually, I don't really understand why it's stuck here. It should have done it in one huge chunk and then left. Let me restart this.